recently accomplished research onto pieces. And today is time for results section. So what we are going to do, I will introduce basically grading criteria, and then we will go in the Google Docs over several manuscripts, so about half dozen, not the complete manuscript, but only results section, and share critical comments. So basically everyone to everyone. And it will take approximately an hour, and then in an hour, so during this hour one can switch off the camera and sound, and after an hour I will invite everyone to come back and we will go through the comments, giving authors a chance to defend their work against criticism of the reviewers. So if you were not able to join previous meetings, all our meetings are recorded, and comments from group members' feedback is also recorded, so one can implement them a little bit later to upkeep the schedule. Stephen, thank you for sending last minute contribution. I will give a brief overview of the grading criteria and then place your draft into the Google Docs, so that when we will go to a mute mode, so that no one feels bored. Okay, show the screen. So we are doing this procedure since we follow an advice of ancient Romans, divide and conquer, where we are not dividing and conquering countries, but we are dividing manuscripts and conquering them by pieces, because by small pieces it is a little easier. So each of us does play a role of reviewer, and while going over masterpiece of someone else, one can comment on several aspects. If the text of the results section refers to all figures in a subsequent order, because in a true life, reviewers get upset if the someone refers to the figure number 6 at the very beginning, right? It's very childish and simple, but we do not want any paper to be declined because of this miscounting figures. So while going through, it is often, it will be not unusual to see if some paragraphs are not needed, and reviewer has the right to suggest author to remove a paragraph if it is not clear why it is needed here, or put a doubt that it is needed here. Also, a week ago, we went over the conclusions, and 2 weeks ago, we went over abstract. So by now, it seems clear, or almost clear, what is the goal of each paper, and one can judge content of the results on the following criteria: whether it supports the statements in the conclusions, and whether it helps to achieve the goal stated for the paper. Another criterion to check just a style of a good essay. Very often, and I'm not criticizing anyone personally, I'm based on my poor experience at the beginning. When I used to start something writing, it very often occurs just as a collection of statements which are not connected to each other. And if someone is really enthusiastic about subject, it's not a big issue. One can extract useful information, but picky reviewers will not like it. So it should read as a good essay. If possible, reviewers may try to give a one-sentence summary of the logic of the paper. For example, upon learning the electronic structure where energy levels are positioned, one is running molecular dynamics to find trajectory. One uses this information to find transitions between those electronic levels. And at the final stage, these transitions are used to compute the dissipation of energy from the system. Something like that. It's basic, and in many papers we repeat the same pattern of logic. But if you see it in the paper you are reviewing, give a credit to the authors that it is a clear logic, and connection of pieces is easy to follow. If as a reviewer you see that something is misplaced, please do not hesitate to swap an order of statements. Sometimes just swapping order of paragraphs or sentences make it read much better. And if some information is redundant and boring, again, do not hesitate to recommend author to shorten and remove things. So in case there is a really strong pressure, a very oversimplified and poor way to write results section is just to extract captions of the figures and slightly rearrange them. So basically explain what each figure is about. And sometimes we all work under pressure, it's understandable, but it is better if it is improved. So is there a technical explanation of what is shown in the figure? Is there explanation of trends learned from the figure? Is there summary of new information that follows from the certain figure? So again, in a very basic and approximated way, results section is just a composition that jumps from one figure to another and tells what new information you learn from there. And if you see it, just give credit to the author. If you don't see, suggest to follow it. And there should be a little place for human emotions. So if you like something, or if you see that author is inspired and impressed by his or her own results, give a positive comment. So it's completely legitimate if the author makes a comment after describing certain trend or certain result, like it is a record efficiency of charge transfer, or it is something that goes counterintuitive from everyone's expectations, or it shows the product of reactions that we didn't expect, or opposite, we did expect. So some emotional comments referring to accomplishment of original goals are welcome. So wherever possible, I was trying to place this grading comments at the end, at the bottom of each document, and here is the list. So after we start, I will add a link to draft by Steven, and then if you have an hour, maybe we should target to spend 5 minutes per work, although I understand it's probably not possible, but let's try our best. Are there any quick comments objections or suggestions, or it generally makes sense. Okay, thank you for nodding and supporting this style. So let me invite everyone to just go forward and edit. And in about an hour from now, I will invite everyone to come back to active mode and share feedback and give authors a chance to defend. Meeting will be recorded. I hope it will be a successful recording. And if by some reason your schedule doesn't allow you, you can see both comments and feedback in the recording. Number one is the work of Kea on single oligomer. So Amir is asking, we are debating it each time about either chopping sentences independently or merging them together. It's a matter of taste of author. The second, it's not clear who is like what is subject, object, and what is the verb. So I think it is just grammar to fix. Just maybe without rush, read and edit.
Yeah.
So Samir suggests to highlight that luma plus 1 and n equals 2 refer to the same orbital. And generally, there was a comment, I think from myself, later on, that at the very end of this paragraph, there is a disclaimer about naming. So maybe this disclaimer about namings can be moved to the very
up.
Yes, to the up, and then it will help to understand.
Okay, sure.
Okay. Well, observed, happened is relates to humans.
Yeah.
Well, here you highlighted single oligomer. It implies that you want to compare to multiple oligomer, but formal reviewers of this paper will be not aware of your second paper.
Okay.
So, what do you mean? It's good comment.
So what should I write instead of single oligomer?
You can either remove sentence or a single oligomer in comparison to multiple oligomers known from literature.
Okay.
We have divergent opinions with Amir. He wants longer sentences. I suggest shorter sentences. But you are free to act as you feel better. Okay. Look for the way to maybe rewrite the sentence to make it more.
Okay.
It was clear for me because I looked at the figures for a long time. Orbital distribution, charge density distribution. Same thing. Oh, sorry, so let me come back. Yeah, you're here. Instead of think, maybe the word trend. Happened, observed.
Observed. Okay. Not.
So again, here is just grammar confusion because it's not clear who is actor, what is the action, and what is the obstacle or circumstance. Like particle of the box doesn't promote anyone anywhere. So maybe it experiences it, or a human observes. Just play with language. Language not as like grammar, but definition. We humans observe that something that system experiences. Okay. This positive integer is index of eigenstate. Let's go further. Amir wants more clarity. Yeah, in what follows, I have no doubts that you understand what you're doing, but from the language,
okay,
it's not clear. Are you speaking about transition energies on x-axis or intensities on y-axis? And also maybe a disclaimer about labeling could be offered. Like Roman alphabet is used in ascending of the transition energies.
Okay, sure.
Yes, it is what Sarah is mentioning. So peak A is not the highest transition energy, it is lowest transition energy, but highest intensity of absorption, right? Okay. So I think it was just little, if you were in a rush, you may have swapped X and Y labels. Refer to equation about this TDDFT, and if it is not covered in the methods, maybe one can add an equation.
Okay.
I'm fine, but you can check with Amir what he means. And since he left because of some deadlines, we cannot ask him.
Grammar.
Okay. So
shown.
Amir is very meticulous reviewer. So his focus.
It should be are shown.
Agreement with what?
Oh, the agreement with what?
With each other. So results obtained by different functionals qualitatively agree with each other. So it's not peaks, but results of HSC and PB agree with each other, right? Let's ask this answer to Sarah. Sarah, would it fit your question?
Yes, thank
Okay,
you.
thank you. Amir wants to discuss dashed line. Okay. So Aaron is asking, how do experimental and computed results agree? And to my understanding, he doesn't need you to answer right now, but to put a little text in your draft. Aaron, is it right?
Yeah, I just didn't see it mentioned.
Mm-hmm. So even if they do not agree to 100%, it's okay, it happens. Just mention. So the transition energies seem to agree, but in intensities and positions of peaks do not. And likely it is because here we look at a single oligomer, and in experiment there is an ensemble.
Sorry, Professor. So for the Aaron's question, what he suggested, like,
Add a sentence comparing dashed
Mhm.
and solid lines.
okay,
If they partially agree, just claim it. If they partially disagree, also claim it. So we are not hiding it because figure is already shown. Correlation function. So Sarah requests meaning. Maybe, and it looks like there is a next sentence related to this meaning. So maybe it indicates that some readers can be impatient, and as soon as something potentially strange is said, you can add as explained in next sentence or as explained in what follows. Sarah, would it satisfy you? Okay. Yes, Amir wants technical details moved to methods. Yes and no, you can decide. Probably the methods already have definitions, and here you just use it to focus attention of the reader. I agree with Aaron. Breaking,
Okay.
using shorter sentences is always good.
Mm.
Why did you select the transition? It's a legitimate question, and you may look on the draft by Samir, which is number 3 today. He makes an attempt to explain why a certain transition is selected. So it could be either most intense absorption, or maybe one wants to have at the same time intense absorption and relatively small transition energy, but some criteria why this one is selected. Maybe it's the simplest one behind Homo to Luma, simplest one that involves some relaxation. Just, but Amiris probably just needs some text about this explanation.
Okay.
Sense? Yes. Okay. Would you agree?
Okay, I will do that.
Okay. I would, Kia, please answer to, Aaron is asking if the figures, panels B and C are consistent.
Yeah, they are consistent.
Okay, so the answer is yes. Sarah suggests some change of the wording.
Okay.
Amir likes 10 picoseconds, but I understand why you are using this notation, because it's easier to compare with figures. So you just take number from here and put it into the power of 10.
Yeah.
Here, this highlighted sentence can be moved later when you speak about the wholes.
Okay.
It's very strange when one speaks about one and another and then swaps back. Yeah, if you swap, if you move blue sentence to the lower place, then a question will disappear. Aaron was asking, what do you mean under 1D? And let me advocate.
One dimensional.
Yeah, one dimensional. Aaron, make sense? Okay. Foreign couplings are stronger. Aaron thinks that it is one of the main results of your paper and wants more text explanation.
Okay.
Why?
Mhm.
Those things, all peaks are visible in the integrated emission plot. Yeah, so it's a language. And let's quickly look. So arrangement of figures provide path for explaining main results from the dynamics. Focus narrative on statements which support reason for appearance of M prime peak in PL. Does the slow Hall cooling have anything to do with M peak? Yeah, it's really great comment to add if time allows, and maybe to the discussion. Any other questions to Kia? If no, let's move forward to the one by Aaron. And I think in next works we will have less comments, so we will finish quicker. So very few comments to Aaron, which means it's either everyone is fearing to say any word against him, or it is written perfect, or it is very hard to understand. I hope not the last. So I was trying to be picky, but it's truly hard. So what was the reason to find difference? Probably it's just visual identification, right? Here you refer to Frank-Condon spectrum, inclusion of phonon bands. Would it be permitted to call it nuclear reorganization effect? Is it the same as you were doing in your recently published paper when nuclear interatomic distances change upon photoexcitation?
Yeah, I think that's involved in the calculation of the spectra.
Okay, then you have a chance to cite yourself and call it like related to nuclear reorganization as computed in, and then cite yourself. Okay. Charge density distribution. So I don't know, was it intended or you want to expand, but it looks like there is a list of trends which maybe you plan to expand. And even if you don't, maybe one can number them. And then in discussion section to provide explanation for each of them. Like if Hall relaxes faster, often it is for a higher density in the valence band. Maybe something else, but adding analysis would please the reviewer. Why certain annulation extend lifetime? Does it relate to rigidity and lesser amplitude of motion? Here, I just try to understand the sentence, and it looks like unconjugated annulation increases intensity and other two effects decrease intensity. It was correct interpretation?
Yeah, I think.
Okay.
It's hard to describe because there's two changing variables at once, or two different functionalizations. So it's kind of hard to specify like when it changes from like pi to charge transfer.
Okay. But exactly as you've told right now, those human emotions are often appreciated. So if you summarize that there are competing mechanisms and it's not always possible to say which one wins, it will help reader to follow what is happening. So it's summarizing. So there were no filling of the table. More questions to Aaron? Some comments, criticism? If no, let's go to the next one. So I think this draft by Samir is what this is a second in amount of comments. First one was the one on singular ligament. Mead suggests to change wording, and we should be critical to the suggestion because TDSMD was used at the very last portion of this work. Well, it is written this way anyway, so just focus on the wording of the sentence. Mead suggests to exclude methods section. So David Graupner is asking why it is important to mention the absolute index of the orbital. Samir, are you here? Would you like to answer this question if David will listen to the recording?
I don't know if it matters exactly. It was just added information that we included.
Okay, let me thank you. Let me advocate. Depending on the pseudo potentials and basis set, the absolute indices can be different, and these absolute indices are needed if one compares. One should be careful about indices if one compares different bases, but using universal HOMO and LUMO could be a good idea. I think I didn't answer anything, but it was a comment. Basis Mead suggests starting point is fine. Dr. Han is asking, what is excitation calculations? Samir, do you refer to absorption spectrum or initial conditions for the dynamics?
I think it was initial conditions because later on it says the absorption spectrum right under that.
Okay, thank you. Where is this? So same for impatient readers, one can add shown in what follows because it is in the next paragraph. So Mead is asking, he's curious to see HOMO minus 2 to LUMO plus 2, and he doesn't observe it in the figures. So Samir, was I correct that referral to HOMO minus 1 to LUMO plus 1 originates from analysis of oscillator strength file?
Yeah, that was how we did it.
Okay. Yep. So maybe it can be later placed, a portion of this file can be placed in the supporting information. Let's go further. The largest one, but is quite so Mead suggests some reasonable wording, so maybe one can added. So relate features of absorption, intensity, and value of transition energy to selection of the state as initial condition. And even if this is not an ideal wording, maybe it's something that can be borrowed by Kea to her work. So you see that some moderate possibility of activating, well, in Kea's work, there is no chemical reaction, but find language to explain why certain state is selected. David Grauper is asking why figures 2a and 2b are in different section, and I'm answering that because they're based on different methods. Samir, do you approve?
Yeah, that seems right.
Okay, thank you. So this question by Dr. Khan is something that we will face from true reviewers if upon submitting. So why potential energy surfaces are not directly extracted from DFT? Why some parametric values are used? Because, well, I should take this question. It's possible, but it would take additional effort. So results here were something that one can do in a very short time. So there is nothing wrong in trying to extract potential energy surfaces from DFT. This is a natural extension of the work. Mead suggests to swap two sentences. I think there are two sentences highlighted here. So, Samir, if you find it applicable, please follow. Aaron is asking, is it the population transfer between potential energy surfaces due to non-adiabaticity? And I did answer yes. But here, again, to have everything completed as a really brief calculation, the couplings were assumed as a parameter rather than computed. And again, computing non-adiabatic coupling could be a very reasonable extension of this work. So those are cool ideas that would make expand one paper into 5 papers. Okay. But for we shouldn't hide and make secrets. If it is selected as parameter, we probably should mention at some place, maybe in the methodology. Mead is asking if it is absolutely the same initial condition.
I was actually just saying how like that sentence could just like give a one sentence summary of the figure
Oh,
other
okay.
than like its initial condition.
Okay. Samir, do you understand what Mead suggests?
Not exactly. Could it be said again?
I don't know, unless I'm wrong. The first sentence just says like what the initial condition is, but like if I say figure 2, I'll say figure 2 is a absorption
okay.
spectrum.
Okay. Whew, finally, I understood both of you. Let me add a scenario of interatomic distance expansion dynamics for the same initial condition as shown earlier. Mid, would it
Yeah.
satisfy?
Yeah, that's right, because this was when we excited the molecule versus 3A was where we didn't.
Okay. Okay. So, and typically most of the questions of the true reviewers in the future will be not about criticizing methods or results as scientific value, but just to add clarity and definitions. I think here it was a typo. It was tail, like fairy tale. Snapshots of 8 methyl iodine molecules via. So Mead suggests some different updated wording, which is worth to consider and maybe implement. Dr. Han is asking why this transition is used as initial excitation. Are these orbitals localized on one methyl iodide molecule? So this is a good, let me try to answer. This is a good hypothesis, and it is already, it is mentioned later, and Mead is asking if it was done. So this series of questions, last 3 questions, suggest an additional calculation which is quite inexpensive and can be added at a no time. So it is suggested that one plots the orbitals for an ensemble of these 8 molecules and shows that orbital HOMO and WOMO plus 3 would likely sit on the same molecule. So this would avoid ambiguity and help reader to get through, as we see from the 3 questions. So David probably was, oh no, David questions about different. Mead and Yoon, would this additional figure satisfy your curiosity? Okay, yeah, thank you. Samir, would you think it will be possible to do?
I think we could, yeah.
Okay, good. So there is no rush, but maybe before we finish all sections of the paper, one day one can add another figure to supporting information with orbitals for ensemble model. Okay. David Graupner find challenging to find these labels. Okay, I don't know what to do. Maybe expand the figure or use bigger fonts or keep as is.
I don't think we added all the hydrogens. We only had the carbon and iodine. So
okay, then if they're missed, maybe one can modify the figures, and quickest way would be just to write over the figure a text rather than redoing actual figures. But either one, maybe it's not a bad idea to add the labels. Next. So Mead thinks that this sentence was a critical comment of someone, and I don't remember how this text appeared here. Maybe it was just a comment to help reader to prepare for the next section.
yeah, I don't know how that got in there either. Maybe some weird like differences between Google Docs and Word.
Okay, but anything which is not needed for for conclusions and what potentially irritates reviewers should be removed. So if there is no reason to show the sentence, maybe it's healthier to remove it. So here is another question from Dr. Hanvi, which is it's a deep question that could be asked by future reviewer. So the question is, are the transition energies the same? Is the excitation for DSMD promotes electron from the ground to the second it has to be checked, and there is and ideally it should be so, but there is a chance that in the accomplished TSMD, the excitation goes not to the second but to the first pass potential energy surface. Again, I do not have a definite answer, but if just from common sense, if it would be from ground to the second potential energy surface, then the number should be at least bigger than 8, because lowest 8, like LUMO to LUMO plus 7, would correspond to the same type of LUMO orbital in isolated molecule, slightly hybridized to each other. So maybe additional calculations in this situation are too much, but at least by plotting orbitals for ensemble, one can get more certain answer to this question and comment what is the real situation. Okay, yeah. And Mead has some suggestions about using the text, moving text from figure caption to actual paper, and he doesn't like when one figure refers to another figure. I don't know, it's a matter of taste. And Mead makes some interesting comments in the reviewing form. Could go into more information on difference between two systems. The paper discusses the bond length difference, but is there anything else? Samir, would you like to answer to me in briefly?
We also looked into where the electrons went, and I think we saw that it might change the way that these molecules could bond to one another, but that was our main focus, was the bond length changes between the CH3I.
Okay.
Yeah, so like, just out of curiosity, your like abstract or introduction would state that you're specifically just looking at bond lengths mainly? Like,
Yeah.
well, like, because I don't know weight packets at all, so like, are there videos involved, or is it just a calculation with weight packets?
Videos are involved. I'm taking this question.
Okay, because like if you have videos, then like it'd be cool to like compare the two videos, right? Or like two different snapshots. Yeah, and I know Samir, you're kind of, I believe you're in high school, right?
Yeah.
Yeah. So I understand time, and this is all on your free time, I assume. So this is a lot of work for you. So these are all just suggestions. They're not, mandatory by any means.
Okay. Are there more questions to Samir's paper? Questions 1, question 2, question 3. Many thanks for all enthusiastic comments and discussion. Let's go to the paper by Sarah. Aaron tells that it is not clear what the main observable is. Okay, let's live with this statement for a time, and then declare what is the main observable. So first, critical comment. Aaron is asking if a reader is supposed to know vast keywords. Maybe no. So Aaron suggests to use the values of spin and up down as a part of this definition of.
Yes. I just wanted to say that in the method section, I just wanted to put an up down formula as one equation, as we had in my report for the project of the class project. Yeah.
Okay.
Yeah, I just wanted to mention the equation for an up down in the method section. So then the readers will be familiar with an up down. What do you think, Dr. P?
Yeah, it's good. And published paper by Amir explicitly uses these keywords, which was a little strange for me. I was not giving comment like this to Amir, thinking that formal reviewers will make my job, but they accepted it. It's not common, but sometimes paper may come through this unusual style.
And also several your previous papers you shared with me, they use an up down in their figures, in their
it's my fault. It's my fault I didn't catch this.
But they explicitly says what is the equation for an up down and what is the meaning of it.
Okay, and later on I do have a comment, we will arrive to it, that it's very good and relatively long text. So reviewers who are not focused need help in navigating through this text. And it looks like from the first paragraph, you're going to compare results for different spin multiplicity. And then you will select different observables, and for each observable, you will scan over the three multiplicities. So this can be learned from the first paragraph, but it's better to remind. And maybe one can add, right now you do have names of subsections, but it's possible to add subsections.
Okay, I see.
Just put the word high spin, low spin, intermediate spin at the first word in the paragraph and highlight it in black. So for highly intelligent reviewers, it's not needed. But for those who are sleepy and not focused, it may help.
Okay.
For all spin configurations, upper part of the valence band is dominated by O2P orbital character. Even tells that it's not always truth. So for some configurations, there could be occupied iron orbitals at the top of the valence band. Is that what you mean?
I mean that if you take a look at the figure 2, the partial density of the states, you can easily see that for the upper part of the valence band, the green line, which is correspond to the oxygen, has the most contribution. And also I saw this behavior in other
So let's just avoid this discussion. So please return if you do not like my comment back. So would you be agreeing to each other if you say it this way? Typically upper part and then continue.
Yes, as you can see in the next sentence, I reference to 4 papers that they observed the same behavior also.
Okay. So and it is completely normal to use a little less certain statements if you
Yes.
expect that there will be exceptions.
Okay, yes.
So even is asking, are they focusing on the same system using the same method?
I
Do
just
not spend time right now, but those references should be described in more details in the introduction section and highlight there if it is same method or slightly different. Like, can we attribute possible difference in results to use of different methods? Even would it satisfy? Okay. Iron brings energy level mostly in the upper part of the valence band. 5 iron. Well, again, it's not always. So typically, iron orbitals are inside the gap, not in the valence band. Maybe we can use a little more vague, uncertain language. It's not an ultimate truth. Maybe do not do it, but consider to tell, or in certain cases, something like this. If it is not a common, even would it be better? Okay, thank you. Criterion to select initial photo excitation. I didn't notice explanation. Maybe you plan to do it in the methods, but it is natural question as you saw in the previous.
by the initial photo excitation, you mean that which
For dynamics, like photo excitation from HOMO -17 to LUMO +2.
so I put it here, but you mean another thing? I mean, I put that the initial photo excitation is from HOMO -17 to LUMO +2. So you mean another?
Why? Why?
What was
Not
Oh, okay.
which orbitals were selected, but there are like 200 possible initial excitations. Why you selected only this one?
Because of the with this excitation, this transition has the most, the strongest oscillator strength. So I should mention it in the.
Yes, yes, and it will be easier to follow.
Okay.
Thank you.
And can
Yes.
you scroll up a little bit? You also said something here, iron related orbital are expected to be inside the gap of, what do you mean by this?
Energies of correct me if I'm wrong. I was telling intuitively.
Okay. Oh, okay.
Okay. What are the subgaps in the valence band and conduction band?
How to calculate this, Dr. Klee? Subgap in valence band and conduction.
Are energy differences between like LUMO +1 and LUMO, or HOMO -1 and HOMO? Why are you asking this question? Do you want to make a connection between?
Yeah,
Mhm.
I guess typically electrons should be relaxed faster, right, than holes.
Okay, I
So
see.
here,
I see. So, Sarah, I think Yvonne wants you to have a tool to explain why holes relax faster, or oppositely, electrons relax faster. So the rate of relaxation is related to the subgaps, and just looking on the density of states, one can approximately tell what will be relaxing faster, electrons or holes.
In this case, the holes are getting.
Generally, in any case, let's quickly go to the figures. So when levels are dense and there are no offsets, for example, high spin down, so all holes are close together, and here hole relaxation will be very quick. And for electrons, there are sub gaps from one electronic level unoccupied to another unoccupied. There are big energy differences. So here the electrons will relax much slower than holes. So what you will be suggesting, not to give exact numbers, but tell that based on density of states, we can attribute, we can analyze and attribute quicker or slower relaxation to the fact that density of states is higher or lower, or that there are available subgaps. Make sense?
Yes, kind of.
Okay. Okay. Okay, let's go further. So, as a bad reviewer, I lost focus. I have forgotten what is the order, and as a bad reviewer, I would appreciate if each paragraph has this label which spin multiplicity deals with, maybe as a first word in the paragraph.
Why you make it red interband?
No, I just I was trying to focus on what I'm reading. There is no reason. Okay. And we are very short in time, but let's think as your little homework. Think on the answer of Aaron's question. What is the main observable? In his own works, in the works of Aaron, main observable typically is the I have a cold telling that my time is up. The ratio of intensity to the rate of relaxation, which will tell whether the luminescence will be efficient. So it's not the question to the content of the paper. It's just a suggestion to identify what is most interesting observation and declare it as the main observable. And I do not have a clear answer. Aaron, do you have suggestion what could be the main observable for Sarah?
No, nothing really. I couldn't find anything that jumped off the page while reading.
Okay, but let's think on it. It would be it's a good idea to help to have some flags on this territory that will navigate reader. Okay, more questions to Sarah? Yes,
Dr. Klein, for the last figure, is it what you want? The last figure, figure 8, yes, is panel.
It's beautiful. It's beautiful.
Panel G is okay. Thank you.
Yes, and it is exactly what would make this figure. Maybe observations from this figure can be related to answer to Aaron's question. I'm just not sharp enough to make this two words connection. Whew. Let's go.
Thank you.
Thank you. So we have 3 more, but they have much less comments. We'll finish quickly. Aaron suggests that Amir explicitly tells that it is HSE 06 because there are several other brands of HSE. And I suggest that peaks should be labeled, which would make it is much easier to analyze to discuss the figures. Aaron is asking if explicit labeling is needed. Even if it is not needed, maybe one can keep it for a time and remove it at the last instance. It's just as a scaffold. So Aaron summarizes that comparison of Fuller and non-Fuller non-Fuller is more favorable band gap, but Amir is planning to add excited state dynamics, and then results will be more logical and more interesting and appealing. So it's a work in progress. So next work, multiple, I would say, not a single oligomer, but ensemble of oligomers by Kia. So you will find some statements redundant. Samir, yes, I would put question marks also. Band gap of the any system helps to predict the behavior of the system. So it's maybe one needs to make connection and explicitly tell, like, knowledge about oligomer helps to describe ensemble of multiple oligomers. Okay. So it's a question about language. The general idea to avoid questions like this is just to chop sentences, make them so short and simple that there are no ambiguities. So Yulun is asking what is actually injected, positive or negative charge, and it could be a typo. So it's double check. To my understanding, here is one is speaking about the hole. So injecting positive charge or extracting the electron. Kia, am I correct? Okay, is not here anymore, then you'll be very quick. Charge carriers. What's the meaning of charge carrier? Either electron or hole, to be to have a to be more general. No, they're not labeled, but they need to be labeled. Okay, so there were some suggestions. Yeah, this is a beautiful figure, and I think it will justify many results. And here the chains are not labeled, but putting labels on them would help to understand. And definitely, it is too much graphical information for main text. One would need to keep much less, maybe one or two examples, and push most of this orbitals into the supporting information. Okay, and the draft by Stephen. So I found figure 1 and a reference to figure 1 and figure 3 and missed reference to figure 2. So are all figures referred in subsequent order? I would say no. So even if there is nothing to say, one could add reference to all figures. Aaron makes a comment that spectral shifts, one should be very careful and use while moving 2 nanometers. Depending on the base transition energy, shift of 100 nanometers can mean very different things. Like if the band gap is 1 electron volt, then 100 nanometers will be like 0.1 electron volt. If the band gap is 6 electron volts, then 100 nanometers would be the same as the band gap itself. So additional comment of using this unit should be done. And some people, to my knowledge, use benefit of this inconsistency. Sometimes making Skisser operator in the nanometers is more efficient than practicing Skisser operator in electron volts. But this tricks should be declared while using. So it's it may bring benefits, but it should be clearly disclaimers. I mean, strong metal to ligand charge transfer behavior. Aaron is asking, what is strong? Intensity or charge separation distance? Stephen, can you please briefly answer this question?
Yes, I believe it would be intensity.
Okay, so it's optical intensity. This is optically induced transition with high intensity. But the separation of charge doesn't go to large distances.
Yeah.
Okay, so we are terribly over the time. So I think we are done with all good agreement of computed spectrum experiment. Increased intensity can be attributed by pi transitions with increased conjugation. So Aaron did a good summary of logic. Yeah, thank you. So many thanks for everyone for this vivid participation and comments and discussion. So plan for the next week is discussion section, but if you have updates to your results sections based on today's discussion, maybe we can glance on them next week as well, because results and discussion are the same story, and there is no reason to go to discussion when results are not ready. So let's plan to have the discussion done, results done for sure for everyone, and discussion as possible. Feel free to send versions as early as they are ready. Do not wait for my reminders, because I'm not the best example of organization, and I'm sending reminders too late when there is no chance to change anything. Okay, many thanks. Everyone is welcome to disconnect, and I'll stay here to answer questions one by one if any.
Yeah, I have a few, Dr. Kuhn.
Yes, please.
Are you sure? We just had a long meeting. Do you want a break?
If I set a break, it will be long. We can, if you really want, we can meet like maybe in an hour or in 2 hours at 9 if you have long discussion.
No, I've been going to bed a bit early. It would, I guess, is there a better time for you if it's kind of like a more than a 15-minute discussion?
Yes, we can. Let's meet at 9 then. So send me an email and then we'll speak without time pressure.
Or at 9? Okay. All right, sounds good.
Okay, yeah, thank you. Okay.
Hello, Professor.
Yes. Okay, we already went through your second paper, but amount of comments was not as big. You'll see it in.
Okay, so I need your help for the explanation of the second paper. Like, can you open that one? Do you have time to just give me some suggestion?
Okay.
Second paper. Sorry, second figure.
Yes, I understand.
Figure 2 means I didn't.
It's the figure itself.
Yeah, so I didn't wrote anything for the figure 2. Yeah, figure 2. There is nothing.
So the main result, as I would present this paper, I would take where the green line intersects y-axis, where yellow line intersects y-axis, and where purple line intersects y-axis, and record these numbers in a table or just and refer to it as to the main result. So observe, but something is, you need to redo the panel A once again.
Panel A.
Panel
If-
A needs to start transition energy from 0 electron volt.
Okay. Okay, sure.
And then it will be main result, and based on this main result, we will arrange the remaining results and details as a support. But please redo figure A by starting from transition energy equal to 0.
Okay.
Not from point A, but from 0.
0.
And it is main criticism, main thing. Before it is done, the rest of things are very secondary.
Okay. So I will do it today and send it to you. Then after that, you will write the little bit like how to explain those things, because it's
Oh yes, about this figure 2A, I elect to write myself something. Yes.
yeah,
And
it's really difficult.
yes, it's. I would be happy, and it will take not long. Yes, let's do it.
Yeah. Okay. Then thanks.
Okay. And for your first paper, the comments were very detailed, and when you listen our recording, you will be happy.
Yeah, I was there, so I will do that, and also I will today I will able to send this figure by today.
Excellent. Thank you so much.
Okay. Thank you, Professor. Bye.
Bye.
Yeah. Bye, Elon.
How are you?
Good, good. How are you?
Very good, very good. Thank you. I did registered